So let us look at the inverse Fourier transforms. Okay. So the formula corresponding to this is f of x is 1 by root 2 pi integral minus infinity to infinity f of alpha e to the power minus I alpha x d alpha. Okay. So this is the inverse Fourier transforms. Okay, let us use this formula to find the inverse Fourier transform of f of alpha, which is e to the power of minus alpha square. Okay, so let us find this. Okay, so yeah, by using this, let us substitute f of alpha there. This. So f of x is equal to 1 by root 2 pi minus infinity to infinity e to the power of minus alpha square into e to the power of minus I alpha x into dx. So we can write this as 1 by root 2 pi minus infinity to infinity e to the power of minus, if you take outside, so this is alpha square uh, plus I alpha x, okay, into d alpha. Okay, so let us try to expand this. Okay, so this, so um, this is alpha square plus I alpha x. Okay, now what I do is I add x square by 4 and subtract x square by 4. Okay, and I multiply this here, this 2 times I alpha x by 2, right? And now put this as minus and this is plus x square. I'll just rearrange this. So this whole thing, I can write this as alpha plus I x by 2 whole square. Okay, plus x square by 2. Okay, so this has transformed into this. So let us rewrite this. E to the power of minus within braces. This is alpha plus I x by 2 whole square uh, plus x square by 4. Okay, d alpha. Okay, now I can take this since this is constant term x square by 4, can take it outside and let us write this. So this is f of x, which is e to the power of minus x square by 4 divided by square root of 2 pi, and this is minus infinity to infinity e to the power of uh, that is minus of alpha plus I x by 2 whole square. Okay, so d alpha. So let me take t as by substitution, t as alpha plus I x by 2. Okay, so since this is constant, so dt is d alpha. Okay, so as there is no change in the limits, which is same, So this is e to the power of minus x squared by 4 by root 2 pi minus infinity to infinity. This will be e to the power of minus t square into dt. Yeah. Now we'll be using this as uh, integral t here, which is 2 times of f of x dx. Okay. So here a is infinity here. So I can write this as 2 times e to the power of minus x squared by 4 divided by root 2 pi, okay, 0 to infinity, e to the power of minus t square dt. Now, as you know that integral 0 to infinity e to the power of minus x square dx, which is root pi by 2. Okay, so so this further I can write this 2 by root 2 root pi to the power of minus x square by 4. This is uh, root pi by 2. So these it's cancel 2. Okay. So f of x is equal to 1 by root 2 e to the power of minus x squared by 4. So this is the inverse Fourier transform. Okay. So let us find the Fourier transform for the function. Okay, it is 1 when mod of x is less than or equal to a, or 0 when mod of x is greater than a, where a is a positive integer. Okay, and hence let us evaluate these two. Okay, now uh, so the function exists when the mod x is um, is less than or equal to, that is in between. So using that is inverse, let us try to solve that. Using the Fourier transforms. First thing is f alpha is 1 by square root of 2 pi integral minus infinity to infinity f of x e to the power of I alpha x. Okay, so let us try to solve this. So here x is in between the mod of x, okay, which is less than or equal to a, or x is uh, plus a minus a. So this will be 1 by root 2 pi integral minus a to a f of x, which is 1 into e to the power of I alpha x into dx. Right? So let us evaluate it. So what we have is f of alpha, which is 1 by root 2 pi e to 1, this is e to the power of I alpha, right? So integrating it, so you get e to the power of I alpha into x a, right? So this is e to the power of mx dx, which is e to the power of mx by m. Okay, so here it is I alpha. Okay, so which is 1 by root 2 pi to 1 by I alpha e to the power of I alpha a minus e to the power of minus I alpha a. Okay, so now using the identity e to the power of I theta, which is cos theta plus I sin theta, e to the power of minus I theta, which is cos theta minus I sine theta. So uh, you have this, right? So e to the power of I theta minus e to the power of minus I theta, which is 2I sine theta. So here with referring to this, so you can write this as 1 by root 2 pi into, this is 1 by I alpha into, this is 2I sine alpha A. So this one term gets cancelled. So I can write this as root 2 by root pi, and I gets cancelled. So I get sine alpha A by alpha. Okay. Or I can write as a root 2 by pi sine alpha A by alpha. Okay. This is your f of alpha. Okay. Now let us use inverse Fourier transform. Okay. So which is f of x is 1 by root 2 pi minus infinity to infinity f of alpha into e to the power of minus I alpha x d alpha. Okay. Using the substitute f of alpha, which we just found in this, right? So substituting it. So f of x is equal to 1 by root 2 pi. This is minus infinity to infinity. So root 2 by pi sine alpha A divided by alpha e to the power of minus I alpha x into d alpha. Now e to the power of minus I alpha x, I can write this as cos alpha x minus I sine alpha x. Okay, so let us do that. 1 by this gets cancelled. Okay, root pi and root pi is pi, 1 by pi. Okay, minus infinity to infinity. Sine alpha A by alpha cos alpha x minus I sine alpha x into d alpha. Okay, now we can split these two here. So f of x is, this is 1 by pi. Okay, integral minus infinity to infinity sine alpha A cos alpha x divided by alpha d alpha minus I by pi minus infinity to infinity sine alpha A and sine alpha x divided by alpha d alpha. Okay, so we are able to split these two, right? So as you can see, the second integral, the expression is an odd function. So you can neglect this. So considering only the first term, okay, so your f of x becomes 1 by pi minus infinity to infinity sine alpha A cos alpha x by alpha d alpha. So taking to the other side, pi on the other side, so minus infinity to infinity sine alpha A cos alpha x by alpha, this is d alpha, okay, which is equal to pi x. Now this can be now f of x we have seen the problem itself. F of x is 1 and 0. Okay, so this will be pi and 0 for x less than or equal to a, and for mod x greater than a. Okay, now we got this result, that is integral minus infinity to infinity sine alpha a cos alpha x by alpha d alpha. Now let us interchange alpha to x. Okay, interchanging alpha to x. So hence we can evaluate this. So cos ax, sorry, sin ax in ax, and this is cos alpha x divided by, this is x into dx. So we got this result. So pi 0 for alpha less than or equal to a, for alpha greater than a. We got this result. Now in this, if you substitute alpha as 0, okay, so let us substitute it. So we are substituting here alpha as 0. So cos 0 is 1. Okay, so let us substitute it. If alpha is 0, sin ax by x dx is equal to pi. Okay, so alpha is 0. Now again, minus a to a f of x dx is 2 times 0 to a f of x dx. So using that, so this is 2 times 0 to infinity sin ax by x dx is equal to pi, or integral 0 to infinity sin ax by x dx is equal to pi by 2. So we got this result also. Okay, this is simple.